Hello and welcome to Beamer Folk.
Seasonal greetings. It would be probably best for you to look at the video concerning this configuration that is linked to here. It pertains to a Poundland battery pack. I think it was called Geek, a Tesco's radio, and a couple of leads to adapt and switch the 5 volts to the 6 volt DC input of the radio. And this configuration here worked perfectly. The only problem I have with it is that this battery pack, after a year, has lost half its capacity to store energy. And this video is all about how I've replaced this battery pack with another one which I ordered from a well-known auction site, and the problems that I encountered in doing that. It looks as though all battery packs are not equal. Now this is the crux of my problem. You can see that I've managed to eliminate one lead. Let's give it that lead, which is the switch lead, because my new power bank actually has its own on-off switch, which was good news. Got rid of one lead there. And size-wise, this power pack is called a Power Solve, incidentally, and the previous one, just to give a size comparison, it's a little larger, that's all, but thinner as well. So yeah, same volume, or similar volume anyway. Whilst this is superb, I noticed that the Tesco radio wasn't receiving DAB and FM as well as the Poundland. There appeared to be some form of interference, and under certain weather conditions, where I would imagine the signal strength for either was particularly low, it would break up. And the Tesco radio that I've got actually has an error indicator, and you can measure this as a percentage of error, or the number of errors on DAB. You don't have an error meter on FM. The location of this power pack and radio is in our bathroom, and the reception there is not absolute brilliant. So the AGC systems within the radio bump up the RF effectively, which of course makes it more sensitive to whatever noise is going on within the local vicinity, and the noise is emanating from the power pack. This was not a problem with the Poundland power pack. Actually, this worked very well indeed. I didn't really have a problem with it, except, as I said, it lost its ability to store charge very quickly, within a year, 50%. Now, it looks as though this particular power pack, and I don't know whether it's true of all other, but I would imagine it's a problem that is common to power packs, that their RF emission, both radiated emission and conducted either via the USB lead, varies from one manufacturer to another. So I fell in love with the capacity to store charge on this power pack. I only need to charge this power pack once a month to power the radio completely. Furthermore, as I've quite enjoyed this system, I also use it to power a digital storage oscilloscope, one of these cheap and cheerful things that looks like this. And I'm sure you're all familiar with them. And I noticed, as this was a fairly recent purchase, I noticed that this DSO, this little DSO, played up quite badly with this power pack, and it even played up with the excellent Poundland one. And in fact, it doesn't actually power on at all. It actually oscillates between on and off. Interference, surge currents seem to be a problem with these power packs. So I scratched my head trying to look for a solution, and in a moment, well, I'll show you the circuit diagram first, but I did come to a satisfactory answer to all this, and I'll show you that after we've just looked at the circuit diagram of the little device that I've employed.
Okay, so here we are at the circuit diagram of this simple USB filter. You have a USB plug here where that plugs into your power pack, as simply as that, and on the output here you have the USB socket. When you purchase these, and I bought these from well-known auction site, they arrive in a biscuit brick format, so you kind of snap them off. On the output of the USB plug, it just simply, there are two connections that literally travel across with isolation holes here in the middle of the toroidal coil. On the input, directly connected to the 5 volts from the power pack is a 1 microfarad capacitor, and on the output of the common mode choke I've got 2 microfarads. You can reduce this, you can increase this. I found this to be best for me. You can improve the filtering of this by including ceramic capacitors here. They operate better at high frequencies, but as I didn't need them, I didn't include them, and I don't really have the high frequency analysis equipment to work out whether it's an improvement or not. So that's that. And incidentally, it appears as though, and I put a link in the comments below, it's not advised to put a capacitance greater than 10 microfarads across a USB plug. And from what I've gleaned, that's because it causes a surge current which trips the power packs into thinking that too much current is being drawn, and it goes into automatic shutdown, switching off the 5 volts. So they advise no greater than 10 microfarads. The USB socket, well, let's go to the next set. You can see how I've constructed this out of strip board, and it's got basically 6 lines with the isolation in the middle there. I'll go now to the next slide. And here we are, we can see clearly the common mode choke. And when I check the frequencies of the power pack switching, I just put a single coil wire through the middle of this to determine the frequency at which it operates, the power pack operates. How I constructed this, the plug I put into a USB power pack, drew a line across here, and then soldered the wires to the positive and negatives here. That's the positive and that's the negative. That's the 2 outer pins. And then using a bulldog clip and super glue, I stuck that to the surface, making sure that you've cleaned both surfaces, which is true of this as well, and roughed up the surfaces a little bit and put super glue and literally just glued them in place, holding the 2 parts together with a bulldog clip. You can see the capacitors here, 1 microfarad, and there's a 1 microfarad missing, that's on the underside of the board. I use the same super glue here for the socket. The sockets arrive from a well-known auction site. The links for both a plug and a socket I'll put in the comments below. You can see how I wired this USB socket up. And I've made a connection to this point here. I've linked the negative supply to this point here. This enables, if you wish to earth this, this enables the screen of the wire going from the socket here to your radio or to my little DSO scope. It enables the screen to be taken down to a low impedance source. What I found in my bathroom, which suffers from low signal strength, I've wrapped a wire around the cold water feed pipe to the cistern, and via a crock lead, a test crock lead, clipped it to this point here, and that has improved the reception of the radio. But it works okay without it, but it's better if you have an earth connection to this point here. I didn't worry about such things when connecting to the DSO. Now I'll go to the final clip here. Let's see if there's anything else to be said. Yes, you can see how the copper side here is drilled in the center here to keep isolation. There's also a pattern of drilling here to stop these connections, to isolate these connections from the backs of the pins on the socket and the metal enclosure. I kept that isolated from these connections because if you're not careful, a short could occur, and that would be disastrous. A brief comment about the new power pack that I purchased. It's a 9,000 milliamp hour power pack, and surprisingly, unlike the Poundland power pack, this actually performs to this capacity. In fact, I got slightly more than 9,000 milliamp hour, but that could be tolerances error within my measuring system. But nevertheless, it was surprisingly accurate. And now we'll get back to the rest of this video.
I hope that diagram was clear to you, and in a minute I'll show you the trace. For what I did was put a wire through the toroidal common mode choke device to determine the frequency of oscillation of these power packs, because they're using switching technology, as we all know. The frequency here, and I'll show you the trace in a second, the frequency of this device, which was the Poundland device, is 1 megahertz. And let's now just go away and see the trace. That was the trace for the Poundland power bank, and I'll now show you the trace for the Power Solve power bank, this one. And the switching frequency of this is 500 kilohertz, half the frequency of the Poundland power bank. And that, of course, is part of the problem. The frequency of this is half the frequency of the Poundland. So I needed to take that into consideration and see whether this circuit that I developed, actually solved the problem. And I'll go into actually powering up the radio and the digital oscilloscope in a minute, and we can see the effects of this. Although I have to say, in respect of the radio, not wishing to challenge the copyright rules of sound reproduction, I'm afraid I won't be able to demonstrate to you the various interferences, but you'll have to trust me on this one, and that is that it's had quite an effect using these power banks on interference, and it's interference that I needed to solve. Incidentally, there are circuits on the market that keep these power banks alive when using low current, but as the DSO's current drawn from the power bank is 200 milliamps, and as the current drawn, would you believe, for the little Tesco's radio is about 100 milliamps, whether you use FM or DAB, both of those were well in excess of the minimum amount of current drawn to below which these will turn off after a couple of minutes. Anyway, I'll show you now the trace for this power bank, this Power Solve power bank, and next thing beyond that we'll demonstrate the problems. To demonstrate the problem that I had with this little DSO, oh, incidentally, this is a converter that I made. It's one of those little printed circuit boards that convert 5 volts through to 9 volts, because a DSO requires 9 volts, and there's that little converter inside this cardboard tube. The cardboard tube, incidentally, came out of a foil, a foil roll pack, the centre core. It's quite tough cardboard, and you can cut it to size. In fact, I made this a bit too long, really. But nevertheless, it serves its purpose, as they say. I'll just demonstrate what my problem is with it. So here we are. I'll plug in. This is of course the Poundland power pack, and if I plug this into it, I don't know whether you can see that, but let me reduce the light level so that you can possibly see. But you're getting this pulsing on and off, and that isn't just the problem. If you manage to connect it at a sort of particular moment, it will power up, but there is interference which is affecting this DSO. The filtering inside and regulation of this DSO is probably not brilliant, and it's picking up the switching RF from the power pack via this twisted wire. So I'll show you now the my most recent power pack and see what effect that has. Let's just unplug that and then plug in this one here, which is there. Now this, of course, has a switch, so I can power it up with the switch. And you can see that this one actually powers up for that moment, but sometimes it doesn't. And when you get into the DSO, you find that there are disturbances within the time base and triggering caused through an interference from the supply line through to this. And bearing in mind that this power pack is running at 500 kilohertz as opposed to the Poundland one, which runs at 1 megahertz. And whilst that is working, and you'd think I'd be very happy with that, I'm still not. Forgive the low light conditions here, because I'm just about to power up this oscilloscope with my latest power pack. Here we are. Switch that on, and it immediately switches on, which is fine. That's promising, isn't it? And there we are. Let me increase the just so that it's well within the triggering range, and there we are. That's okay for that one, and so I'm reasonably happy there. But let's see if it works on the Poundland battery pack, which is where the principal problem was. Well, the severest problem. It wouldn't power up easily, would it? So let's just plug that in there. Am I in shot? Yes, I am. And there we are. It powered up immediately. I don't know whether you saw that, as compared with the way it used to work. And here we are. So it looks as though I can use this latest pack now for both my little radio and the DSO, thanks to this common mode choke design, very simply constructed on a piece of strip board, and I suppose I'm a happy bunny. But what the future holds with other power packs, I don't know. It's a shame that there isn't a consistency in the design and electromagnetic interference on these power packs, but I have a strong suspicion that compliancy in respect of EMC is probably the last thing that these manufacturers are thinking about. And of course, in our country and a number of other countries, you couldn't put a product on the market without it being expensively compliant. Here's from my power pack problems, hopefully solved for the moment anyway, and I'm wishing everybody a healthy and prosperous new year.
This is Beamer signing out for now.